Hi students, this is your video for example 5 and 6 of your 5.4 notes. And we're going to discuss another transformation. So up until this point we've talked about amplitude, and that's the value in front of the function. And then we talked about the transformation when we minus or add a value at the end of the function, which turns out to be your midline. So now we're going to focus on when we have take away a value or add a value inside the function, so inside your parentheses. Hopefully we're all okay with knowing what our amplitude is for these three functions, because I just look at the value in front of the function, and since nothing's there, it's understood to be a 1 for all three. Now I also know that my period for cosine x is 2 pi. Not sure about these two, so I'm going to go to Desmos. And I have the functions in here already. And I just want to be clear on how to use Desmos. If you don't have a window like this, you go to this tool and you can tell this how far left you want to go, how far right, how far down, how far up. So typically, because we want two full periods, we'll go from negative 2 pi to 2 pi. Our step will be the increments we're moving in. And because, again, up to this point we've been doing in quarters, so it would be pi over 2. And then, how low and high, I'm going to leave that alone since I can see the graph. And just make sure you're always in radians. And so here is 2 full periods for cosine. I'm going to zoom out just a little and move it down so I get a better idea of what it looks like. So here again is the cosine graph. Just to point out some things we know is it's symmetrical with the y-axis. It starts at a high point, hits the midline, low point, midline, high point. Those are your 5 key points. And then you can go in the other direction and so forth. So I'm going to get rid of these, and I'm going to take a peek at this graph that was given to me. All right, I'm going to take it away again. There's the cosine, and here is when I minus pi inside the function. We can see that it has not been vertically stretched at all. It has not been horizontally stretched or compressed, but it looks like it's just been a shift. So, if I look here and I follow this point, it looks like on the green graph, it moved here. If I follow this point on the black graph, I know they're on both, but I'm focusing on the black graph, looks like it moved here. If I follow this point down here, I'll move these guys, I'll get rid of them so you can see more. Okay, so if I focus on this point, it looks like it moved here. So I'm going to take that away and let's compare to the other one. Again, it looks like just it moved left or right. So to figure it out, you just start anywhere. So I'm going to start here on the black graph. It definitely didn't move right because I don't see a high point near me on the right side, but I do see a high point on the left side, which is up here. Not that one. There, this one. And if we follow that, look, see how our outputs are 1? It looks like our inputs went from 0 to negative pi over 2. But this is plus pi over 2. So that's letting me know that it's actually going to the left pi over 2, not to the right like you probably most likely would think. And we could play around with numerous graphs, but this will always be the case. So what we see here is, well, our period remained the same for both of these, right? And again, that's just talking about how long it takes to start repeating itself. So when you add C, you're going to shift to the left C units. And if you subtract C, you're going to shift to the right C units. All right, so let's go ahead and look. We're going to ask you to graph all of our transformations. So we talked about what that 3 means and what that -1 means. So we know the 3 is our amplitude. And I should have asked this, but I'm just going to write it down right here. We also know our midline is -1. Y equals -1. Don't just say -1. It's an equation of a line. And our period, because we saw that the 3, the -1, and when you add or subtract something inside your parentheses, it does not affect it, so it will remain 2 pi. All right, I'm going to, before I start graphing this, I'm going to give a sketch of just what sine originally looks like. So it's going to be a brief sketch. Looks like my outputs now are called f of x. Or no, forgive me. Let's change that. Let's name it something new. G of x. And so I'm saying g of x is my sine function, just so I know what I'm comparing it to. So I give myself quarters, make it 2 pi, give myself quarters, and this will be 1. So sine starts at your midline, high point, midline, low point, midline, low, mid, high. And if that's still a little bit rough for you, you can always refer to your unit circle to see where those values are coming from. All right, that's your original graph, known as your parent graph. This is telling me, let's go ahead, get rid of this. This tells me 3. I'm going to vertically stretch it by a factor of 3. This tells me I'm going to move it right pi over 2 units. And this guy tells me I'm going to shift it down a unit. So the easiest way to go ahead and graph all these transformations is to always graph your midline first. So I'm going to use this information right here to help me with my scale. Nope, not that. You want to be consistent. Okay, let's put that right there. And then because I'm moving up 3 and down 1, I'm just going to make every tick mark be a 1. You only have to label your x and your y once, and then the reader knows what increments you're working in. So like I said, the first thing I'm going to do is I'm going to graph my midline. And what I want to do now is if I compare to up here, so I originally started at the midline, right? Well, if I vertically stretch that, it's not going to go anywhere because my output is 0. So 0 times 3, it stays on the midline. So that 3 doesn't affect that red point I just made. But I do have to shift it down a unit, right? So now I'm on that new midline. And then it looks like this tells me I need to go right pi over 2 units. So that means I went from here down, and then I want to go right. It looks like I'd end up right here. So I always just look at my first, and again, it doesn't matter where you start, but I'm going to start my period here at 0, 0. So it looks like my very first point, and I'm going to erase these so don't make it on your paper. My very first point originally was here. I shifted it down a unit, so it's on my midline, but then I have to shift it right pi over 2. So this is my very first point. So I'm going to go ahead and erase these guys. Okay, go back to my red. Now let's look at, forgive me. Now let's look at, you have here, here's your end of your period, right? So I'm going to go and erase these guys so it doesn't confuse you. No. Very finicky, this thing. I'm learning as I go. Okay. I am now focusing on this red point right here. So remember, that means it would go down a unit and then to the right pi over 2. So my very last one would go down a unit to the right, which it looks like I'm going to be a little bit off, so I'm going to make it right here. So these 2 points I just made are the beginning and end of one cycle. And we talked about graphing sine, that halfway between the beginning and the end of your cycle, you hit the midline again. So I can figure out 1, 2, 3, 4 coordinates. So 2n, I'm going to hit the midline again because I'm halfway between. Well, halfway between here and here, I have a high point. But now my high point has to go up to 3 from the midline. So let's go ahead and get rid of these guys so it's not confusing. So halfway between would be here, but I have to go up 1, 2, 3. So there's your high point. And halfway between these guys, I'm going to have a low point. So going down 3 units, 1, 2, 3. So I have right here 1 full period. Of this. Now that's 1. I want to get a whole other one. So I can just emulate this on the other side. Or we can know we have our entire cycle. It took us from here to here is 1 full period. And we already talked about that's 2 pi units long. So I'm going to go ahead and go on the other side another 2 pi units long. So 1, 2, 3, 4. It ends on the midline. Well, halfway between here and here, I hit the midline again. I'm going to get rid of those. So that means 2n. 1, 2, so I hit the midline again. Halfway between here and here, again, just because I know what the sine curve looks like, if I'm going in this direction, I'm going to have a low point. So I have to go 1, 2, 3 below. And then halfway between here and here, I'm going to have a high point. So 1, 2, 3. Get rid of this, get rid of this. And so I'm going to continue. And there's 2 full periods of this transformed graph. Now to bring back some other things, what's our domain for this graph? Well, all real, because I can put any angle I want into this function. And our range for this graph, well, the lowest it hits is -4, and the highest it hits is 2, which makes sense because my height is 3, but I shifted it down a unit. All right, see you next time.